Hello students. In last lecture we have seen the classless addressing concepts and how we can find out the first address in a allotted block, how many numbers are there, number of addresses are there in particular allotted block. Now today we will move ahead and find out the last address, how we can find out the last address of a given block and further things. So suppose let's start with an example. In the given question, find out the last address in the block if one of the addresses 140.120.84/20, and we all know now this prefix length /20 is the key of this particular classless or a CIDR notation addressing of IP address. So a random address is given and you have to find out the last address. So what will be the procedure for it? We can see. So in this case, like previous examples, we have learned how to find out the first address, and the first address was this. And the number of address is this on the basis of 2 to the power 32 minus prefix length, right? To find out the last address, we need to add 4095 to the first address. Means what? 4096 minus 1. I think we have discussed so many times that first address will be the network address. So apart from this, because 4096, this first address is included. So that particular address is given at the time of the allotment of the block. So minus 1, and we have 4095 different addresses in a particular block which belongs to this address belong to this particular block. So now what will be the last address, value of last address? We have to find out that. So with the help of this number of address figure, which is 4095, we can find it. We can see 2 or 3 methods similarly like we used in how to find first address. So the first method is, we know that 256 base 256 mathematics or arithmetic is used in this particular addressing concept. So if we use base 256, I think everyone is very much aware of this base mathematics. Like if base is 256, then number will be divided by the 256 only in every step. So if we write 4095 as 15.255, how we get this number? If we divide 4095 with 256, then it will, the quotient part will be 15 and the remainder part will be 255. So we can write it in the IP address form 15.255. This is the philosophy of this base 256 method. Now we can add this number 15.255 to the first address of our block, which is given at the time of allotment, right? So if you want to find out the last address, you should know the first address and total number of addresses. Then we get 140.120.95.255 will be the last address of this given random address. Okay, so only base 256 mathematics is required, which is the concept. We can see some more easier methods too, so through which you can easily calculate the value of this. Now see the alternate method. Now write down the last 2 octets binary value of your first address, which is this. Then write down the 4095 number of addresses in binary and add these 2 values. Again you will get the same value directly, 95.255, if you convert this result into decimal. So this can also be a method through which you can identify the or find out the last address with the plus operation between these two, right? Now one more method is there, find the last address in the block if one of the address is this. Suppose random address is the given here and you have to find out the last address. So solution is very simple. Now if you see the prefix part, which is 20, right? So we can also say the mask of CIDR notation addresses. So in this case, mask has 21 and 12 zeros, total 32, right? Now complement this value. All the 21, 20 ones become 0 and remaining zeros becomes 1, and convert it into binary. Again, you will get 15.255, the same value, and add it into the first address. Then you will get the last address of a given block, right? Now you can see the method. So in this method, a very easy thing is there. We know the prefix length value is based on 1. Put all the ones and then remaining will be 0. Then complement it and convert it into binary, and add the resultant value added into the first address of a block. So in this way, you can easily find out the last address in a given block. Now find the block if one of the addresses is this. In such type of question, when only block word is used, then you have to find out three things. Number one, first address, right? Number two, last address, and number three, total number of addresses in a given block. In previous examples, we have seen specifically mentioned their first address, last address, or number of address. We can handle it separately. No, a simple question is there. Find out the block. So one by one, we will find each and every thing, 1, 2, and 3. So we follow the procedure in the previous examples that we have seen, that find out the first address, the number of addresses, and the last address. So to find out the first address, last three methods were there. You can use any one to find out the first address, right? So if you see, we notice that the mask 29 has 5 ones in the last byte, obviously. So we write the last byte as the power of 2 and retain only leftmost 5 bit shown below. This can also be a method if we convert 202. Now you can see that 202 is the last part. If we write it down this, then leftmost 5 numbers are this. So if we convert it into binary, it becomes 200. Okay, so this will be your first address, or you can choose any method which we have learned previously. Then number of addresses, you know very well the formula, to the power 32 minus the prefix length value. So 32 minus 29 becomes 3, and to the power 3 equal to 8. Only 8 addresses will be there in this particular block. Now to find out the last address, it's very simple. We can use the complement method of the mask. Then 29 ones are there. If we complement it, then it becomes 0 and 3 ones are there. So it will become 7, because 3 ones becomes 7 in decimal. So now add this particular 0.0.0.7 into your first address, which is this. So the final last address will be 190.87.140.207/20. Okay, so this is the method through which you can find out the process of finding the complete block detail, right? So this is the method. Now show a network configuration of this previous example. So you can create the diagram. The overall address block range is this 29. I think the value written in this particular slide was wrong. It will 29, treat it as a 29. Now see the configuration. These are the addresses ranges from 200 to 207. 8 addresses are there. First address is always be a network address, which is your this interface address. Then after that, from 201 to 206 will be the addresses for host or client. And we all know the last address is also reserved for broadcasting and some other purposes. So we can't allot it to any host. So in this way we can configure our network, right? So this is the method through which in CIDR notation or classless addressing, which is very much useful to avoid the wastage of IP addresses, right? So this can be a question for you. You can find out with yourself, practice problem. And these are the few notes. If you can see in classless addressing, the last address in the block does not necessarily end with 255. Obviously, you can clearly see that in case of classful addressing class ABC, whatever address is allotted, every octet will start from 0 to 255, right? But we have seen in classless, last address was 207 or maybe something like that, because we are giving or allotting addresses in pieces or in variable size blocks on the basis of users need or demand, right? So in this classless inter-domain routing notation, the block 100 is defined by the first address and the prefix length. Always remember, the first address and the prefix length will be given to you when you go to the internet authorities for allotting address in your for your organization. So this is the overall CIDR notation concept which we have seen in two different lectures. Rest we will discuss in next. Thank you.